flipped classroom series, and we're looking at Chapter 7, and this is Exercise 2. My name is Mr. Gill. So you should all have this particular handout here, and today we're looking at multiplying polynomials by binomials. Now, before we get into the examples, we want to do a little exploration here. So let's read through this and see, look at this particular scenario that we're presented with. So Joe keeps cows. In the summer, he likes to allow the cows to graze in a big field, and he has a river that runs alongside his property. So what he likes to do, he has 50 meters of electric fencing, and he likes to go through, and so his cows can get some outside time. He likes to create a rectangular paddock. And he's only going to use three sides, fence off three sides, because guess what? The river that runs along here, like this, it's kind of acting as one side, and apparently cows are scared of the water, so they're not going to get into the river. So he's going to use his 50 meters of fencing to fence off three sides there like that. Now, let's have a look and read on here. Joe loves thinking about things mathematically, and he decides he's going to label the widths of the field with an X. So we're going to call this dimension down here the width, and he's going to call this X, and of course the opposite side is going to be an equal length. That's also X. Now we've got a question here. Look at the first question that we have. What would be the length of the field? Now we want to be able to express the length of the field, which is, this is L, the length of the field long there, and we would like to express it in terms of the X's. Now let's think for a moment. What if he decided he would make the width of the field equal to 15 meters? So that would be 15 meters there. Over here we would also have X is equal to 15. Now, if he uses 15 meters of his electric fencing for the widths of the field, what's going to be left to make up the length of the field? Well, let's think about it. Doing a little bit of a sum here. He's got 50 meters total, and he's used two lots of 15, so it would be 50 minus 2 times 15, and that's easy mental math, isn't it? 50 minus 30 would give us 20 meters of fencing, wouldn't it? So we would have 20 meters along there, and if we were worried about or interested in calculating the area, we would have 15 times 20, and 15 times 20 is going to be equal to 300 square meters, isn't it? Now, instead of we picked a specific example of the width of the field being equal to 15, what if we just leave it as an X? Well, look what we had here. Up here, we had, when X was 15, we had 50 minus 2 times 15, which was 20 for the length. So if we replace that with an X there, could we say that the length of the field is going to be the 50 meters that he has total, and subtract the two values of X there? So 50 minus 2X. So that there, the length of the field we can write over there, would be the 50 meters, take away the two lengths X. All right. So what's interesting about this is that this expression here, of course, that's a binomial, isn't it? And remember that the width of the field is just a single term there. That's a monomial. Now, the next question that we have here is, what is an expression for the area of the field? Now, we know that area is equal to width times length, isn't it? So if we go through, we know that the width of our field is equal to X, and the length of our field, well, it's going to be 50 minus 2 times whatever X is, so 50 minus 2X. So guess what? There we have. We have an expression for the area of the field, don't we? So there it is there. Now, what's interesting to me here is that this is the product of what? Well, it's the product of a monomial X and a binomial 50 minus 2X. Now, let's imagine here, Joe decides he will make the length of X to be equal to 10 meters. So could we go through and calculate what's the area of the field going to be if he does that? Well, we can write down the area is going to be equal to, now what we need to do is we need to, what's the word that we use? We're going to substitute or replace the x with the value 10. So everywhere we have an x, we're going to write down 10. So we've got 10 for x first of all. We've got our brackets here, 50 minus 2 times 10. Now, we've got brackets here, so we're going to evaluate what's in the brackets first of all. 2 times 10 is 20. We do the multiplication first. 50 minus 20, of course, is going to leave us with 30 there like that. And then we've got the 10 on the outside, 10 times 30, and that's equal to 300 square meters. Now that's not a very big area. If you live on a regular sized city lot at home, that might only be about half of the size of your lot. And if you live on a full quarter-acre lot, that's only going to be about 30% the size of your lot. So it's not a very big area. Okay, so, we actually did that there. Now, let's have a look at the next part here. Joe's buddy Boris says that another expression that could be used is this one here, 50x minus 2x squared. So is Boris correct in saying this? All right, we used, of course, Joe came up with x and then brackets 50 minus 2x. And Boris is saying, well, the area could also be written as these two monomials. Now, the way to check to see whether Boris is correct is to maybe go through, let's go through and substitute the x equals 10 in. So what have we got? We've got 50 times 10. What's that? That's 500 minus 2 times 10 squared. Now, if we evaluate that, that's 500 first. 10 squared is 100, so it's minus 2 times 100. Remember, the exponent must be done first. And 500 minus 200, of course, is equal to 300 square meters, which is what we had for Joe's expression. Now, the question arises here is, I wonder how did Joe's expression, which is x times 50 minus 2x, become the same as Boris's expression? Now, look at this. Look at what we're going to do here. Perhaps it works like this. Well, indeed, it actually does. If we take x and it multiplies by 50, now that would give us 50x. And then we've got a subtraction sign there. So that connects the two parts. And then we've also got x is going to be multiplied by the 2x. It's connected by a subtraction. So we're going to have 2x times x, which by now you should know would just be 2x squared. So that's actually how the way it works. All right, let's go through and do some examples. So let's flip over to the next page there. And example number 1, we're going to go through, we're multiplying a polynomial by a binomial using an area model. Now, we've got a monomial, 3x. So on our area model here, we'll let the 3x represent that length down there. Now, the second part there is a binomial, so the 2x can be that part, and then the plus 4 can be this length along here. Now, we've effectively got two little rectangles, don't we? So area 1 is the left-hand rectangle. So if we did the area of that, what are we going to have? We're going to have 3x. So we'll do 3x times 2x. And what do we do here? We multiply the coefficients. 3 times 2 is 6. Xx is x squared. Right, let's look at the second area. Now, the width, of course, is 4. And the height, or the length, whatever way you think about it, is the 3x, isn't it? So what are we going to have here? We're going to have 4 times 3x. So 4 times 3x, multiplying the coefficients, 4 times 3 is 12x. So what's the total area going to be here? The total area is going to be area 1 plus area 2, and that's equal to 6x squared. All right, that part there, plus the second part, which is plus 12x. Now, I want you to think about this here. What really happened here? 3x times 2x plus 4. This seems to be what happened. The 3x was multiplied by the 2x, which gave us 6x squared. And then the 3x also had to multiply times the 4. 3 times 4 gave us the 12x there. The connecting operation in between is the plus there, like that. Right, what we want you to do now is, you've got a couple of examples here in the show you know, so you can go through and pause the tape, and we'll come back. So, for A here, area 1 is just the product of 2x and x, isn't it? So that gives us 2x squared. Area 2 is 2x times 3, which gives us 2x. Now, just thinking about where did those values come from, of course, the 2x is the monomial. The binomial can be split up as the x plus the 3, giving us our two rectangles there like that. Now, what's the total area going to be? Well, area 1 plus area 2 is going to be the sum of these two, 2x squared plus 6x. Okay, pause the tape again and have a look at B. So, for my area 1, well, first of all, we've got the c plus 2, which is the height there like that, splits it into 2, and then the width is just c, which goes there like that. Now, area 1 is going to be 2 times the width, which is c. Area 2, hey, area 2 is just a square, isn't it? It has the same height as the width, c times c, which is c squared. And what's the total area going to be? Well, area 1 plus area 2 is equal to 2c plus c squared, just like that. Okay, let's go over to the next page and have a look at example number 2. Now, in example number 2, what we want to use is, instead of an area model, we want to demonstrate how this might work with algebra tiles. So, we have the product, there's our monomial, 2x, and we've got 3x minus 5. So our 2x is represented by these two rectangles there, x and x. And then our binomial, we've got our 3x's there. There's our 3x's. The minus 5, of course, they're blank tiles, minus 1, minus 1, minus 1, minus 1, like that. And we're simply going to go through and fill in. Now, our first multiplication is the x times x there and there, isn't it, across there. And we keep on filling in x times x. Now, this is going to be a little bit of a tedious process. So I'm going to pause the tape and you can go through and fill it in, and we'll be back in a moment. So did you get something like this? Now look what the product ended up being. So each of the big green squares, of course, represent x squareds, don't they? And then the x times the minus 1 gives us the rectangles, which represent, these are all minus x's, aren't they? Now what did it come to here? What do we get? Well, we've got a total of 6x squared, and then we've got a total of, how many of these x minus x tiles have we got? We've got a total of 10 of them, don't we? So we could write that as minus 10x. Okay, now once again, if you were thinking about this, because at the end of the day we're wanting to be able to think about this always algebraically, so we had a 2x times a 3x, didn't we? That's the monomial times the first part of our binomial, which gives us 2 times 3 is the 6x squared. Then we have 2x times 5. 2 times 5 is 10. And the x, and the connecting operation there is subtraction. Okay. Right, we have one here for you to do, so under show you know, pause the tape, and we'll come back in a moment and see how you made out. So, our monomial, of course, is the 4x, so we stack them 4 high like that on the height there. And our binomial, the 2x and the minus 1, there we have it there, 2x and minus 1. Now, when you filled it all in, is this what you got? So what did this give us here? We have, how many of those tiles? We have 8 of them. So 8x squared, and then the minus x tiles, we got a total of 4 of them, so we can write that as minus 4x. Now, once again, can we think about this another way? 4 times 2 is the 8, and then xx is 8x squared. And then the last one there we've got is 4x times minus 1. 4 times minus 1 gives us a minus 4x. So that's another way to think about it. Right, on to the next page there and our last example. So look what we've got here. We've got a gymnasium floor. The width of the floor, instead of giving us real numbers here, they've given us algebraic terms that represent the length and the width. Now, our width there is 4x, and our length is 5x minus 3, isn't it? Now, what do we ask for here? What is a polynomial expression for the gym floor? Write the expression in simplified form. Well, let's start off here. Area is equal to width times length. So I'll put down my width there is the monomial 4x, and my length is 5x minus 3. So there's an expression for the area. Now, look at the second part there. They want us to go through and simplify it. Now, what they mean by that is we want to go through and we want to multiply this monomial by the binomial. So let's see what we get here. First up, we're going to use an algebraic method here. Now look what we've got. We've got the product of the 4x and our first term in the binomial. So we can write it like this, can't we? We've got the 4x times the 5x. Then we've got the 4x times the 3. Now, it's connected by a subtraction, so we've got 4x times 3 there like that. Now, we want to go through and simplify that, and so what are we going to have? 4 times 5, multiplying the two coefficients, is equal to 20, and then xx gives us x squared. And then the second one, our two coefficients are 4 and 3. It's subtraction, so that's minus 12x. So that there, this expression here, is going to be the simplified expression for the area of that gym floor. All right, pause the tape, and let's go through, and you can go through and attempt these ones here, and we'll be back. So this is what I got to start with. We went through, and we had the product of those two, and then we had the product of our monomial with the 5 there like that. Now look what we've got here. So the negative 3 times 2 is negative 6, x squared. Negative 3 times 5, the plus comes down here. Negative 3 times 5 is negative 15, and then we've got x there like that, don't we? So the connecting operation in the binomial was a plus, wasn't it? So that seems to be what we've got. Now, what we've got there is correct, but what's another way that we could also go through and write that? We could also go through and express that as negative 6x squared. And remember, addition is the same as subtracting the opposite of negative 15, 15x. So probably more commonly we would see it written with the subtraction rather than with the plus negative. Okay, pause the tape and have a go at number B. So is this what you've got so far? Multiplying the two of them. The connecting operation, of course, is subtraction there. So 5 times 11, y, and then 5 times negative 2x. Okay, so 5 times 11, the two coefficients, what's that? 55y minus, and then we've got the two coefficients. 5 times 2 is 10. Now, x and y, different variables, so we simply leave it as xy there like that. So 55y minus 10xy. So that's the end of our lesson. So for class next day, what do you need to be ready to do? You're going to be ready to, once you've done the notes here, you're going to be ready to start. We'll be working from these pages here, starting on page 269, and it's exercise 7.2. Thank you for listening.